What's up, Algebra 2? Today is an async day, sorry. And you are going to work on this brief introduction to imaginary numbers. You're going to open up your notebooks, update your table of contents, imaginary numbers, page 52. Once you are all done with that, there is a 4-problem practice attached to this as well. Make sure you do those 4 problems and submit me a picture of all your work, including a picture of your notes to today's assignment to get your attendance. Complete by 3 o'clock. Alright, so if you need to, pause the video and get this all copied down. Otherwise, we are going to start. So, an introduction to imaginary numbers. So, one thing you may have run into in school before is when you take the square root of a negative number. So when we do things like the square root of 4, the square root of 16, and we type that in our calculator, it gives us an answer. You know, even if it's an irrational number, it may be a repeating decimal, we can get fractions. But if you were to try to plug in the square root of -1 or any negative number into your calculator or into Desmos, so your phone, it would tell you the answer is undefined. Now, that is true, it is undefined. However, it's not 100% true because when you take the square root of a negative number, you actually get what's called an imaginary number, or sometimes they're called complex numbers. So here is our definition. We have 2 of them, and you need to write these both down as well as the introduction to imaginary numbers at the top of your screen. The square root of -1 is I. I represents our imaginary number, our complex number. The square root of -1 is I. Okay, so a couple things you might want to give yourself. This I, this is what the variable we use for an imaginary number. Okay, and you're going to get an imaginary number whenever you take the square root of a negative number. It's not just a -1, but anytime you take the square root of a negative number, you get an imaginary number. And we use I. I is treated a lot like a variable, so you can have 2 i's, 3 i's, 4 i's. So you kind of treat it like a variable, but what it means is it's an imaginary number. Another thing that's really interesting, if you take an imaginary number, I, and you square it, it's actually -1. I squared is -1. Okay? So both of these are tools that'll help us simplify square roots that have a negative number in them. So again, square root of -1 is I. And we can also take into account that I squared is -1. Okay, we're going to use these 2 tools in order to do 4 problems together. So pause the video, get this all copied down so that we can do some examples together. Okay, so let's do 4 examples. So as you can see, examples 1, 2, 3, and 4 all have a negative number inside of the square root. If you were to try to plug these into your calculators, it would say undefined for all of these. But we can simplify them now that we know that -1, when we take the square root of it, is I. Okay, so number 1. Okay, if you haven't copied these down, pause the video, take a second to copy it down. So square root of -64. We can't just say, hey, the square root of 64 is 8. My answer is 8. Okay, it's not that simple. We have a negative, and we need to take that negative out. So whenever you see a negative under the square root, the first thing you should do is pull out a -1. Okay, we can divide 64 by -1, and we can split this up into the square root of -1 times +64. -1 times +64, which again simplifies to square root -1, square root 64. Okay, and using that definition from that first slide, we know the square root of -1 is I. So this entire thing, the square root of -1, is just I. It's an imaginary number. So we just write I. Okay. Luckily, we know the square root of 64. The square root of 64 is 8. So obviously, I said I is like a variable, so I wouldn't write I8. That doesn't really make sense. We always put the I at the end like it was a variable. So we get 8I. 8I. Okay, so the square root of -64 is 8I. 8 times the complex number I. So let's look at number 2. Here we're doing the square root of negative 40, and just like before, the square root of negative 40 can be split up by pulling out a negative 1. So we have negative 1 times 40. We can split that into the square root of negative 1 times the square root of 40. Okay, just like we said before, the square root of negative 1, this entire thing, by definition, is I. It's our complex number. So we have, again, I should be writing the square root of negative 1 behind, but so we have the square root of 40 times I, and that I is on the outside. Okay, but we're not done yet because the square root of 40 can be simplified, and that's where we've done it so many times. We make our list of perfect squares. We have 4, 9, 16, 25. I go about halfway and I stop, and I start checking those. Can I divide 40 by 25? No. Can I divide 40 by 16? Nope. I can't divide by 9, however, I can divide by a 4. So we're going to split this up into the square root, we'll put our I in here, of 4 times 10. Okay, so we get the square root of 4 times the square root of 10, and we got that I. Square root of 4 is 2. We'll attach our I like it's a variable, 2I square root 10. Okay, and that is our answer, 2I square root of 10. Okay, let's go again. Okay, so number 3, we have I times the square root of negative 18. Just like before, we want to focus on taking out this negative. So we have I square root negative 18. I'm going to pull out the negative 1. I times square root of negative 1 times positive 18. We can then split it to I square root negative 1 square root 18. Like before, the square root of negative 1 is I. So we have I times the square root of 18. Okay, I times I is I squared times the square root of 18. And we said I squared is negative 1. So I'm going to continue my work right up here. So I have negative 1 times the square root of 18. Okay, and that's because in that previous slide, I squared is negative 1. So we changed that I squared to being a negative 1. Okay, square root of 18 is not simplified yet, so let's make our list. We have 4, 9, 16. We can stop. 16 doesn't work, however, 9 does work. So we have negative 1 times 9 times 2. Negative 1, square root of 9, square root of 2. We know the square root of 9. It's a perfect square. So we know this is negative 1 times 3 square root of 2. And negative 1 times 3 is negative 3, square root of 2. So this is our solution. I square root of negative 18 can be simplified to negative 3 square root of 2. Okay, it's crazy. We started with an I in our problem, but our I actually went away because we ended up having an I squared, which is negative 1. Okay, 4, you can see we have that same I out front, so you can see how it looks like we're probably going to have a similar scenario. First thing I want to do is I want to get rid of this negative under the square root. So I have I times the square root of negative 1 times 96. Okay, so square root negative 1, square root 96. Square root of negative 1 is I, so we have I times the square root of 96. I times I is I squared. And like before, I squared over here is negative 1. So we want to try to get rid of this 96, so we make a list of perfect squares. 4, 9, 16, 25, 36, 49. We're about halfway, so we should stop. We know 96 isn't a perfect square, so let's start checking. 49 does not divide. 36 does not divide. 25 definitely doesn't divide, and you should see that 16 is the largest perfect square that we can divide 96 by. And when we do divide 96 by 16, we get 6. So we have negative, let me switch back to black, negative 1 square root of 16 times 6. Splitting it up, square root 16, square root 6. We know the square root of 16 is 4, so negative 1 times 4, square root 6. Negative 1 times 4 gives me negative 4 square root of 6. And that is our simplified number 4. Okay, so this is how we use imaginary numbers in order to simplify square roots that have a negative. Because if you try to plug this into the calculator, and I'm telling you now, go try. If you try to plug in the square root of a negative number, your computer, Desmos, your phone, it won't know what to do. Okay, so make sure you have all 4 of these examples in your notebook on page 52, and make sure you go take a picture of this and submit it. Go work on the practice. Go, go, go.